So we're going to talk about how to build this arithmetic logic unit lab. First thing I'm going to do is really take a look at my big breadboard, and I want one of these big ones because I'm going to be working on it for several weeks. Now I've gone ahead and put some of the parts for the first lab out here. So one of the things I've done on this board is I went ahead and laid out positive voltage and ground. Positive is this whole strip along here. Ground is here. It's not connected to anything else, so then I have to jump it to these other strips. And be careful, a fair number of these will have the larger jump, the disconnect in the middle somewhere. You'll see the wider separation. I don't have that on this board, so I don't have to worry about it, but a lot of them do. Alright, so I've already gone through and I've connected positive here. I'm not going to need a ground on this end. To be complete, I probably should put a ground. But I'm not going to. I only need the ground in the center, so I just put the ground there. I'll need ground and power down here. So I've got that set up, and I've got some of what I'm going to need here. Now, because this has 3 labs that build into it, it's really like a mini project. I want to look through all 3 of them at once to start with. I should say at once, but I want to look at all 3 of them before I really start building. So first of all, you're going to go through this, go through the lecture and reading, fill this out. When you get over here, there's a little discussion here about why we need to do resistors. So when we use the trainer, there's an LED connected to a resistor, and the switches are connected to resistors to manage the voltage. But we have plus 5 volts in ground, but our forward bias voltage in all these are somewhere in the, you can see 1.8 up to 3.4 volt range. Most of them we'll use will probably be in this around 2 volts. That means I need to drop 3 volts across the resistor. And I not only need to drop 3 volts across the resistor, but I need to make sure that I've got 20 milliamps or less running through my LEDs so it's safe. So there's a whole discussion here on how we set that voltage and what resistor to use. I would take a look through this. What you're going to see is if you have a 1.5 volt red LED, which is a little lower than it shows, but we'll start to get some light at that level, that we would have 3.5 volts then across our resistor and only 20 milliamps flowing through it. So Ohm's law would show 175 ohm resistor would work. That's not a typical value, so we could take it 180. 220 to 270 is very common to see for these. Now, I could wire up and use 2 of these resistors for every single switch connector. You're welcome to do that. I'd trim them down nice and short and put them on the board close to it. Or we can use these SIP resistors, where we have 8 or 10 or 12 resistors all in one little package that go together. Rather than having a color code, they're labeled with numbers. So this has a 101G, which indicates 1, 0, and 1 more 0. So it's a 100 ohm resistor. A 221 would be 2, 2, and 1, 0. It's a 220 ohm resistor, and so on and so forth. If you had a 102, that would be 1, 0, and 2 more zeros, or 1 kilo ohm resistors. Okay, finally, back up here, I pulled this table and I put all this information for you to look at, the wavelength of light produced. So this is just your basic physical science light you did at one point. Lumens, which is how bright they are, viewing angle. I put the information there. You don't really need it for this. It's just something. I just put it all so you have somewhere nice and neat with the different LEDs contained. Now again, we could use a whole bunch of individual switches, but for this we're going to need 4 switches for A, 4 switches for B, and 4 switches for input. 4 for A, 4 for B, 3 for our selections, and then 1 is a carry-in. So what we want to do is connect all of this so we have just our inputs. Okay. That's where we really want to start building. But what I'm going to do before I get to that is I'm going to look in here and say, okay, what am I going to do when I get done? Next part of this lab is I need an OR, an AND, an exclusive OR. Now since I'm doing 4 bits of those, that means I can use a single one of my 7400 series chips and put it in there and have access to 4 AND gates, have it access to 4 OR gates, have access to 4 exclusive OR gates, which means I can use 3 7400 series chips. Look them up. You've used them before. They do each of those logic functions and use all the gates on them. Additionally, I'll need one that does inverse, and I'll need 6 of the inverters on it. I'll need 4 of the 6 inverters on it. So this week, all you have to do is get your inputs in and then set the inverter up. Okay, and get it working. What I want to do is just look ahead to think about how we're going to manage the real estate. So if I go to the next lab, we're going to do the exclusive ORs, the ORs, and the ANDs. So I probably want to put those logic gates, oh, my printout ended up kind of off there, somewhere close together, and then I'm going to need to do a 4-bit adder. Okay, so we've already in the past used a 4-bit adder, so that will take one more IC we'll put on there. And then I'm going to look, and I'm going to need a set of exclusive ORs and a 4-bit adder, which I think I already have on there. My final controls, so we're going to wire up the switching controls the last week. So you can look, and if we have all zeros in, our output's just going to be A. If we have a 1 in, our output's going to be A naught. If we have a 2 in, our output's going to be A plus B. 3 in, we're going to, I said, oops, that's not A plus, it's bitwise. OR and exclusive OR. This will just put B out. This will just put A or B, and this will put A minus B. So we're going to have all those operations working before we get here. So the key to this next step is we're just going to select which of the outputs from all those we're going to send to the LEDs. Okay, so we're going to need 74 LS 151s. We're going to need 4 of them total when we're done. So looking at all that we have to wire, we can put our input set of switches, and we can have these older blue switches. These have 8. Some of them have 10, some of them have 12. I have these little black ones. They're almost identical switches. I'm just going to put it about as far over here as I can. I'm not sure what that is, but we're going to get it out of there. I might need 12 total inputs when I'm done. So if I look here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So I'll probably put the A's on one side, my B's on the other. I'll probably put my 3 selectors, and I'll put like the carry in here, just to kind of keep them separated. Okay, these sets of LEDs, I just want to wire in and just carefully put them in, straddle this. Let's see if that's going to work. Yep. Okay, now finally, I want to make sure I get these the right way. So if I look at these SIP resistors, if I clip on one end, then it should be, this is a 101, so it'll be 100 ohms. So I'm touching 2, that's why it's giving me that, so I have 2 in parallel. Let's see if I can put just one. There you go, 100 ohms. 100 ohms. Each of these is 100 ohms. So reach 100 ohms from this far left end when I can see the numbers. So I'm going to take that far left end, and if you look down here, I'm just going to put it right here. So it's going off to ground. Note, it is not lined up with the switch. So if you look right here, power comes in to this individual switch. I'll have to do power to each of these switches. This is going to be setup 1. It goes through the resistor in the pin number 2 over here, and then to ground. Now I need 1 ground for all these to go, so that's why this has an advantage. I only have 1 connection to make for this. You'll notice that this has 10 total connections, the one that goes to ground and an extra one on the end. I'll do the same thing down here. Put this one far over there. You notice I already had a wire going to ground for it, and it'll set up for my LEDs out here. Now, I mentioned before, somewhere in that 200 ohm range is what we want, and that's what we really have. We have 100 here plus 100 here. So if I flip the switch on and off, I'll go over and I'll take a wire, and again I would use the little ones with nice bends, but I don't have those here, so I'll just use these. I'm going to put power here, so I'm going to run off the trainer and connect these in the trainer connector. Make sure it's set to 5 volts. The independent power supply on the back of the workbenches also has just a set 5 volt connector on the right side. You're welcome to use it. So right now we should check nothing's hot. LED's not on. We'll make sure everything's working before we move forward to doing any other connections. So I should be high, low, low, and right now I'm connected down here. Let's see what happens if I flip. That's high. That's high. That's low because that's connected to ground. Let's not light my LED up. You have to be careful. You have some nice grabbers. I'm going to use this because that's what I have available here. But I think it's going to break it if I try that though. Yeah. Put these. There we go. So these are LEDs and they light one direction. So I put, there's writing down this side. I should have known I had the other one set up right. Okay. So it's set high now, set low now. High and low. Okay, so I've got A, and I'll probably call this A0123, so that's A3. And I'll come in and I'll connect another. So let's go ahead and connect A2, A1, A0. Now they're all going to be running through my nice resistor over there. You know, this would probably be a little neater if I staggered them on this side. Just broke the wire off on that one. So my entire goal of staggering them is not going to work because I broke my wire. So I have no choice now but to take it to the other side. Okay, so that should set all those. Now I'm not going to light my LEDs until I get some connectors in there. So let's go ahead. And this is a case where I'm going to say again, be systematic. Do not get in a rush and try to wire everything up at once. That's why we have the logic probe right here, is just to test. It's not wanting to go in there. There we go. Okay, let's go ahead and try the next couple. I'm using the blue. I would tell you to be consistent with your colors. So that should get all these working now. Wow, I made these way too long. Don't do this. I'm going to go ahead and leave them though for the demonstration purposes. So, let's try them all. So there's my A. Okay, I'm going to probably set B. I can do it way out in the end here. Or I might do it, you know, just a little. I won't go way out in the end because my resistor. I don't have quite big enough resistor SIPs to cover that whole thing. So I'm not going to wire up B totally, but I'll get, you know, make sure we have our basic connection. So I need a ground connection on both sides. So take a ground and get this resistor to ground. Likewise, make sure this is ground because I got power in the other one down here. So now I've got the same ground set up, and now I can run, I can pick 4 reds in a row set up Bs over here and have those operational. Okay, now finally, for this week's lab, I need to hook up the inverter. So this is the 74LS04. I'm going to go ahead and put that in. I'm just going to put these in as close as I can to give myself access. This is my AND. That's my OR. That's my exclusive OR. I'm missing my OR. Go ahead and put the exclusive OR here. I'll put another OR here. Okay. So, now that I have those connected, I want to make sure and get power. So remember it's pin 14 to this. And I want to go ahead and do ground. Ground over here. Before going on, I'll just make sure with all my connections that I've actually got ground in here and power up here. Just check it that way you're sure. Now if you remember, coming in here, this is an input, output, input, output. So I'm just going to go ahead, I'll stick with my color code I set up, so I'll use blue. I have to cut a couple of them. This length is better for what I did, what I'm doing now, so. So I'm actually going to do the following. Clean my hole up a little bit as I'm getting hooked up. Remove those. Put a shorter one in. Make sure that one works. It's pretty short, so I'm going to make sure. Yep, okay. Now, part of doing that is I can come over right here and connect. And I can come right here. So that's my A3. I have to keep track of which of these is which. But right now, I have A3 goes in, and I jumper it over. It's low. Don't the wrong one in. Should be my hex inverter. So I have an input that's low. Should get an output that's high. It's not. Input's low. Output. That's high. It's low out. That's good. Okay, so now it's going to be time to do some troubleshooting and figure out why this doesn't work. When this is low, why I'm not getting an output that's high. Aha. Because our power, I put this power into ground and not into power. Let's try that now. Okay. Input is low. output is high. Excellent. Flip it, input's high, output is low. This one, input is high, output is low. Alright, so I've hooked up right now A3, A2. I have them right into my inverters. I'll go ahead and I pulled these wires out, but I have this one in. I'll go ahead and put another one back in to get A0, and I'll jump those over and pick 2 more hex inverters. I need to keep track of which of these inverters is 3, 2, and 1. Now, you may wonder, how am I going to get my wires from here to these other gates? Well, I won't worry about jumping from here. I'll just pull off. So if this is A3, I can pull A3 over. Okay, so for the first week's lab, what we need is hooked up, completely working, is my 4 inputs A, my 4 inputs B. My B aren't going anywhere, they just have to go here, and I need to get this hex inverter working for all values of A. You don't have to run them anywhere else, you can just test them with the logic probe, and that's sufficient for the first lab on the ALU.